Okay, when we are reading volumes in graduated cylinders, since graduated cylinders have divisions on them, you have to determine what that division size is before you can record the volume, because you don't know how many places past the decimal to record it. So let's say we're looking at a 100 ml graduated cylinder. If you're looking at a 100 ml graduated cylinder, as an example, you've got 10 divisions between 80 and 90 milliliters, or 90 and 100 milliliters. This is telling you that your division size is going to be 1 milliliter. So each one of these is 1 milliliter in terms of its volume. Okay, so this is my division size. Why do we care about the division size? Well, the division size tells you what digits you are certain up to. So when you're making a volume measurement with a 100 ml graduated cylinder, as an example, you are certain up to the decimal point because your division size is 1 milliliter, okay? If you're recording a volume, you have to include an estimated digit that goes beyond that. So if our volume went up here to 85 milliliters on the 100 ml graduated cylinder, you would need to write 85 point, and if it's falling right on, like the bottom of the meniscus is falling right on that fifth division between 80 and 90, that would be 85.0 milliliters. So your division size tells you that you are certain up until the decimal, but this digit is your estimated digit that you have to add, because if you don't add it, your volume will be wrong. You have to reflect the precision of the measuring device, okay? Okay, if we move on to a smaller graduated cylinder, as an example, here is a 10 ml graduated cylinder. It's going to have much smaller divisions. So on our 10 ml graduated cylinder, if this is 9 milliliters and this is 10 milliliters, you have 5 divisions. So it goes 1, 2, 3, 4, 5. You start counting at the division just after the whole number 9, okay? And you go up to the next whole number 10. So if you have 5 divisions between 9 and 10 milliliters, that means each division must be 0.2 milliliters. Okay, so this is 9.2, 9.4, 9.6, 9.8. So my division size here is 0.2 milliliters. That tells us that we are certain to the 10th place because the division size goes up to the 10th place. So when you record your volume using a 10 ml graduated cylinder, you have to include an estimated digit just beyond that, so you have to go to the hundredths place. So if our volume went up to the 10 milliliter mark, okay, the bottom of the meniscus was at 10 milliliters, what will we record? You would have to record 10.00 milliliters. You have to go to the hundredths place because your division size went up to the 10th place, so you're certain to the 10th place, but this digit here in the hundredths place is your estimated digit that you had to provide, okay? So anytime you have little division marks on some volumetric device that you're using, you have to determine that division size. So that follows here with your pipette that we use in one of the labs, and that also follows with the burette that you use, because it has little division sizes on it as well, okay? So you've got to record a volume that reflects the precision of the measuring device that you're using. Now, what about when we're doing lengths? Okay, when we're reading lengths, so we're using a ruler or maybe you're using one of these triangles, then this also has divisions on it, so you have to look at how big the divisions are. So we're going to focus on the metric side of things first. We're going to look at centimeters. right, typically on the centimeter side of a ruler, there will be 10 divisions between whole numbers. You start counting at the first division just after the whole number. So if this is 2 centimeters, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You go up to the next whole number, okay? So each one of these divisions must be 0.1 centimeters in length, okay? So this would be 2.1, 2.2, 2.3, 2.4, 2.5, and so on. So that means you are certain up to the 10th place. So if you're going to record a length using the centimeter ruler, you would have to go one place past that, which would be the 100th place. So if you fell on the 6th division here, then it would be 2.60 centimeters for the length. You were certain up to the 10th place because your division size went to the 10th place. This 0 is your estimated digit that you had to provide. Okay, that's how you reflect the precision of the measuring device. What if you fell directly in the middle? Well, if you fell between the 8th and the 9th division and I asked you to record a length, this would be 2.85 centimeters. Okay? Now, what if we are looking at inches? Inches is going to be different. For the metric system, you're only allowed to have decimals. For inches, since this is an English unit, you have fractions. That means you have a 16th or a 32nd, and you don't typically simplify those fractions. So if you're looking between 2 and 3 inches, okay? There should be 16 divisions. And if you fall on one of those divisions, we call it a 16th. So, if I fell on that 5th division, you would write 2 5/16 of an inch, okay? You don't simplify the fraction if you can. You leave it as a 16th. If you fall in between, like let's say you fall at 2 and 2.5/16 of an inch. Well, I just told you that you can't have decimals when you're using inches because it's an English unit. You can only have fractions. Well, you can get rid of it. Multiply the numerator and the denominator by 2. It will always be by 2. So that way you can get rid of the decimal. Okay, so 2.5 times 2 is 5. 16 times 2 is 32. So you'll get 2 5/32 of an inch. Again, if you can simplify that fraction, you don't. Okay, you leave it as a 32nd. And that's how you read volumes and lengths to the proper number of places.